What are ball bearings and how do they help machines run smoothly? Do you ever wonder why the moving parts of a machine move so smoothly? How does a fan rotate without much noise? And how a car's wheel rotate with ease? And how do the rotor blades of helicopter move smoothly despite being so fast? And how does a tank's turret rotate? This is made possible by tiny metal balls called ball bearings. Balls, due to their shape, are able to reduce friction between two objects. That's why you can slip and fall down if you try to walk on floor on which lots of marbles are laying. Just like marbles, make it easy for your body to slip against the floor. Ball bearings make it easy for machine parts to slip against each other. Without ball bearings, machines would regularly break down and need replacement of parts damaged due to friction. Ball bearings are responsible for smooth motion of almost all the moving parts of any machine you can think of. Be they car wheels, jet engines, electric motors, or hard drives. In fact, ball bearings are so important for smooth functioning of most machines.
The center part of a wheel on a car is called a hub. The wheel spins smoothly because the hub has bearings inside it. Bearings reduce friction, which is a force that resists motion. A common type of bearing has tiny steel balls that allow the hub to roll around the axle instead of rubbing against it. Rolling produces less friction than rubbing, so having bearings in the hub will make it easier to start spinning and keep it spinning.
Hello children, we are learning about the bearings. So what is a bearing and why we need this bearing? A bearing is having three components. One is the internal ring and the next is the external ring, and in between these two rings there are some tiny balls. So why we need it? Let's check. Consider this biscuit as a wheel and this pencil as the shaft of a vehicle. So what we will do, we have to insert this pencil at the center of this wheel. Okay, now I have inserted the center of the biscuit with the pencil. So what happens is, this pencil acts as an axle and this biscuit acts as a wheel. So if we have connected the axle and the wheel without a bearing, right? So now what will happen when the vehicle is moving? The wheel rotates by sliding on the surface of the pencil, that is the axle. Okay, so if we rotate it like this for a long time, then what will happen? Then slowly the biscuit over here at the center around this shaft, that is the axle, will start to become a powder and it will change its shape. So this circular hole at the center will change its shape slowly and it will make a vibration in the wheel. So the wheel cannot rotate regularly and it will make a vibration in the vehicle. So can you understand this? You can see it. If you rotate it continuously, it will become into a powder. Similarly, the metal objects will also turn into a small powdered form when it is continuously sliding over a surface. So that in order to prevent it, we are using these bearings. So we will insert this bearing in between the wheel and the axle, so that the bearing makes a more smooth movement in the wheel. Okay children, we will make a small model of a bearing. For this experiment, we will need some beads and some cardboard and a scissor. Cut the sheet of paper like this and roll it with your fingers so that it will turn into a cylinder. So now just leave it so you can get a cylinder like this. So you can adjust the diameter of the cylinder according to the balls you have. So we have some balls like this. So we will fill the balls into this. Now check how many balls can be placed around the walls of this external ring. So now we are making the external ring and the ball assembly. So check the number of balls that we can place into the external ring's internal surface. So accordingly, according to the size of the balls and the internal dia you need, you can choose the size of this external ring. Okay, so I have some balls and I have chosen another ring, that is the internal ring. For that I have taken another sheet of paper that is smaller length than the previous one. So again we have to roll it. Okay, so the diameter of this cylinder will be little smaller. So this is the internal ring of the bearing that we are going to make, and I'm going to place it inside it. So now we have two rings. One is the external ring and another one is the internal ring. So now we can place the balls inside it, in between the two rings. Okay, so can you see this? I am placing the balls between the two rings. So slowly increase the number of balls. Now we have an idea about the diameter of the internal and the external rings. So now we can fix the internal and external rings to a base. Now take a sheet of paper like this and roll the external ring to the required diameter and fix it like this with a glue. Kindly be careful while handling the glue. Now let some time to make it dry. Once it's dried, just cut off the extra surface around the external ring. Kindly do it with the help of your parents. Be careful while handling the scissors. So now it's nearly in the shape of a round. You can cut off the external parts. So now we have the external ring. So I hope it's dried, so we can add the bearings. So before that we can fix the size of the internal bearing also. So now we should make some glue internally so that the internal ring can also be fixed. Now the internal ring is also fixed. So now we have three parts: the external ring, the internal ring, and some balls. So now we can add the balls in between the two rings. Children, can you see this? Now we have placed a bearing with the balls around the two rings. So we have now having two rings, one of this at the in center and the other rings at the outer surface. So there are two rings, and now if we rotate this internal ring, then what happens? The balls are in contact with the internal ring and the external ring, and so what happens is the balls rotate. Now we have two bearings. One is the model bearing that we have made, and another one is the real bearing. So similar to the real bearing, the model bearing also has some balls, so in between the external ring and the internal ring. So here these rings are covered by a protective layer, so the balls are not visible. So in between these two rings there are some balls as shown in our model. So now children, can you understand the heat and the friction is reduced by these tiny balls between the two rings, that is the internal ring and the external ring. So we are using bearings in all rotating components like helicopters, cars, and the toys we have, and our bicycle. So all the rotating elements will have this bearing. Okay children, we will learn about more interesting things in the upcoming session. Thank you.